we know decimals are tiny numbers in the number world. And our job today is we are going to learn how to divide decimals. So I want you to think about division. Lots of times when we go to divide, we don't really think, what does the answer look like that we're hoping that we get? And so what I like to do is I like to estimate my answer before I begin. So I have this problem, 839 divided by 58. Not easy to do in your head. So 839 is called my dividend and 58 is called my divisor. So what I'm going to do is I'm going to use something called compatible numbers. Compatible numbers means I'm going to change my dividend to make it a number that's a little easier for me to do mentally. So 839, I'm going to nudge up and I'm going to make that 850. Now it's not the same, but it's close. And then I'm going to take my divisor of 58 and I'm going to nudge that down to make it 50. Again, it's really close to the original number. Now, in my head, I'm able to actually do the division a little bit easier, and this is the way I think about it. I know there's 10 groups of 50, that equals 500, so I have at least 10 groups in my answer. Then I think, all right, if I take 5 times 7, that's 35, so if I do 50 times 7, that's 350. And if I have 500 plus 350, that equals 850. So therefore, my 10 plus my 7 is 17. And notice I have this squiggly line here. So it means there are about 17 50s that fit in 850. And that's what division is. It's how many of these divisors actually fit in the dividend. That's what we're thinking about. So let's take it a step further. Let's say I take this dividend, which always goes on the inside of the division symbol, and I'm going to take my divisor, and it's going to go on the outside of my division. So always think of crossing it. Now, I think my answer is about 17. So let's see how close my actual answer is. So let's go ahead and start to divide. Now, when we go to divide, what I do is I take my hand, and I put it up and I cover all of the digits except for the furthest left digit. And I say to myself, how many 58s go into 8? Well, obviously, 58 is much bigger than 8. None go in. So now I'm going to slide my hand to the right. And now I say, how many 58s go into 83? Well, one whole set of 58 goes into 83. So I'm going to put that one set directly over the 3 because I'm looking at the 83. And 1 times 58 is 58. And I'm going to subtract. So 13 minus 8 is 5. 7 minus 5 is 2. Now I need to pull my hand over to get that next digit. So I'm going to pull that digit down. Now I say the same thing. How many 58s fit in 259? Well, I know that there's 4 of those. So 4 times 58 is 232. And I'm going to subtract that out. 9 minus 2 is 7. 5 minus 3 is 2. And this is what you used to call a remainder. And you used to put a big R, which means there's a little bit more, and you would put 27. Well, the beauty with decimals is decimals replace that R. That's what we're doing when we go to divide decimals. So when we take a look at my final answer, I always want to go back to my estimation. Does it make sense? Well, 14 is not exactly 17, but it's close, so I'm pretty confident that this is my answer. So let's take it a step further. What if I'm going to have a decimal and I'm going to divide it by a whole number? Well, the key here is you have to have a whole number on the outside as your divisor. You have to when you divide. So what I want to do is I always start any problem and I look on the outside and I ask myself, do I have a whole number? The answer is yes, I do. Okay, all I need to do then is take my decimal point and I move it up and I put it in the answer. And then I don't have to worry about the decimal point anymore. And I just begin the process of division. So again, I'm going to cover up all my digits. I'm going to leave only the far left digit, and I'm going to say, can 12 go into 3? No. So I'm going to pull my hand over. Can 12 go into 36? Yes, it can. It can go in 3 times. So I'm going to put a 3 right there. 3 times 12 is 36. I'm going to subtract it, it's 0. And when I pull my hand over to get the next place, I have to pull down that 4. And I start the process again. Can 12 go into 4? Well, people will say no, but it goes in 0 times. So I just put a 0. 0 times 12 is 0. Subtract it out, I have 4. Now I'm going to pull my hand to the right. Notice I skipped over that decimal point. It doesn't matter. I've already placed it. All I have to do is bring down the 2. And I start it again. Can 12 go into 42? Yes, it can go in 3 times. Because 3 times 12 is 36. I subtract it out. 12 minus 6 is 6. 3 minus 3 is 0. I just leave it. Now I pull my hand over to get the next digit, and I pull it down. Notice there's always one arrow being pulled down each line. Can 12 go into 60? Yes, it can. It can go in 5 times, because 5 times 12 is 60. I subtract. When you get down to 0, you know you're done. So my answer, which is called the quotient, is 30 and 35 hundredths. So let's take it one step further. What if I have a decimal divided by a decimal? Well, I still start it exactly the same way. So I have to ask myself, do I have a whole number on the outside for my divisor? And in this instance, I don't. Well, I cannot divide unless I have that whole number. So what I want to do is I want to move that decimal point, which means I'm actually multiplying it by powers of 10. And if I move that decimal point one place to the right, that means I just multiplied by 10. And if I moved it 2 places to the right, that means I multiplied it by 100. And I absolutely can do that. So that just means now I've made that a 12. But whatever I do on the outside, I have to do on the inside. So if I moved it here 2 places, I have to move it there 2 places. So in the end, I get this number right here with my decimal point at the end. Now I'm back to where I was here. I have a whole number on the outside. And when I have the whole number on the outside, all I have to do is place the decimal point. Now I begin the process again. Now notice I use the same numbers. Let's watch what happens to the answer. Again, I cover up. Can 12 go into 3? No. I pull my hand over 1 place to the right. Can 12 go into 36? Absolutely. It goes in 3 times, and I put it right over that 6. So 3 times 12 is 36. I subtract them out, I get 0. And it's like pulling my hand 1 more place over to the right. I bring down that 4. Can 12 go into 4? No, doesn't fit. So it goes in 0 times. 0 times 12 is 0. Subtract. Pull my hand 1 place over. That means I bring down that 2. Can 12 go into 42? Absolutely. It goes in 3 times, because that's 36. I'm left with 6 left over. Pull my hand over, which means I'm pulling that 0 down. Can 12 go into 60? Absolutely it does. It goes in 5 times. 5 times 12 is 60. When I get to that 0, I'm done. And notice I had that decimal point there. Now think what happened. I moved my decimal point 2 places over in this problem, which meant I moved it 2 places over there. You can see the numbers are the same. It's just the decimal point is in a different location, and that's all you need to do. Now, some people like to put a 0 there just to show a number after the decimal point, but if you just left it as 3035, you'd be perfectly fine with that. So I think that takes care of it for us for today. I think it's your turn now. Good luck. I hope you have some fun with math.